Mark, Donald, good evening, good evening. So I'm going to start from where yesterday we are not able to complete this process. Like we are not able to got this process. Okay, we are not able to got this feasible successor. Okay, maybe the problem was at my side or that I don't know. But today when I just configured this router, it is working fine, right? So I'm going to share my screen with you. So this is same router that we used. Okay, now I'm getting comment. Nitesh Sharma, good evening. Neeraj, good evening. Varun, good evening. Yeah. So this is the lab that we used yesterday. And because of some problem, whatever, I don't know, we are not able to get this feasible successor, right? But today I'm having this feasible successor. Okay. So if you over here, hi Nigampa, sorry, actually pronouncing the South Indian name is really difficult. Hi Brijesh Bhai, how are you? So today I'm going to talk about, see this process. Right now, I'm having two paths, right? Suppose if you want to go from this particular router R1 to this particular router R3, we are having two paths, right? Now, if the cost is same, if the bandwidth is same, the cost will be same. And if the cost and bandwidth is same, we will get two successor, right? But today, we are not having the same situation, okay? Wait a minute. I'm going to give names so you can able to understand easily. I'm having two interface. So let me verify the cost. So interface fast Ethernet 0/0. Here it is 100 Mbps. And so interface fast Ethernet 0/1. Here is also 100 Mbps. I changed the cost. Okay, maybe it is not visible, but let me verify this. See, when you give this command, so IP route. Yeah. When you give this command, I have one route. Okay. Now I have one route to send the 50. Okay. So if I want to go through 50, I can send the data to this particular path. Okay. And I'm having another path also. And this one is because of the higher cost, this path cannot be in the routing table. Okay. So if you want to verify this, you have to verify the routing table. Okay. Mukesh Singh, good evening. Bryce, hello. So IP, EIGRP topology. And when you verify this, see, I'm having two root. Like for 50, I'm having two root. Okay, one is 80.1 and one is a 20.2, right? But I'm having only one successor. Why? Because if you count the cost, okay, if you count the cost, 20.2 having the higher cost. And because it is having a higher cost, okay, it cannot be successor because I'm already having the best path, and this best path is a 80.1. So root with the lowest cost becomes successor, okay, and second lowest will be the feasible successor, right? So here I'm having two root, and one is like a successor and one is a feasible successor. Are you getting my voice or not? Can you confirm, please? Are you getting the voice or not? Yeah. Okay. Now it is okay. Now, let me open my mind map so you can able to understand. See this. We have a table. In the table, we have this topology table, right? Okay, right. Got it. Actually, my monitor was problematic. So, okay. So, in the topology, store routing information, learn from the neighbor. I already talked about it. Store each EIGRP route inside the autonomous system. Yeah, each, it means what? Like if you have one or if you have two, it will be there in the topology table. Hold the metric for each, like you can verify, hold the metric, like what is the feasible distance, what is a successor, everything will be over here in the table, in the topology table, right? Now here we have two process like successor. In this particular matter, if you find out over here, like for 50, we have 80.1, which is successor because it has the lowest cost, right? Now, what is successor? We have to remember 3 points about the successor. The first is Successor is a route with the best feasible distance to reach the destination, right? Now, also consider as a primary route. So router will use this route. If I want to send the data right now, router will use this route as a successor, right? This will be the primary route. Okay, available in the both routing table and topology table. Okay, so if you want to find it out, like go to the routing table, and to verify the routing table, the command is show IP route. Okay, so here if you verify this, like for 50, I'm giving 80.1. So this same route is also available in the topology table. So it is available at both the location, right? Now, if you go to the feasible successor, welcome Varun. If you go to the feasible successor, it is considered as a feasible successor route with the second best feasible feasible distance. Okay, also considered as a secondary route or a backup route, and available in the topology table only. Okay, so if you verify over here again, okay, go to the R1. Okay, now we don't have a feasible successor over here, right? So when I will lose this primary route, okay, the feasible successor will be available in the routing table. Okay, so keep this in mind because they are asking this question in the exam as well. Okay, so IP EIGRP topology, and here this is a successor and this is a feasible successor. Okay, now I want to ask you some question. Okay, for example, if you are talking about any protocol, any other protocol, like other than REAP or other than EIGRP, it can be REAP or OSPF. Okay, now the same lab is there for REAP or OSPF. It can be any. Okay, the same lab is there. Okay, and now if this is a main route and this is a secondary route. Okay, this is a main route, like 80.1 is the main route and 20.2 is the secondary route. In any case, like in REAP, in EIGRP, in OSPF, like in any case. Okay, right now assume this, because you can argue that, oh, for REAP this cannot be same because both are 2 hop. I understand this, but I want to asking this question because I want to tell you something more about feasible successor. Okay, that's why. So let me assume that I'm having REAP, EIGRP, and OSPF. Okay, now in the REAP, there will be only one path. There will be only one path. There is no concept of successor and feasible successor. In the EIGRP, we are having this concept of successor and feasible successor, you know, guys, right? And in the OSPF, there is no concept of feasible successor and successor. Okay, now let me start with the REAP. Okay, now suppose PC1 is sending the data to PC3. Now data is going on, data is passing on, right? Like PC is sending the data to PC3. Now suddenly this route goes down. Okay, now suddenly this route goes down, like the primary route goes down. Okay, the connection between this particular router R1 and R4 go down because this is a primary route and it is down. Can REAP change the path and can REAP send this data to the 20.2? Yes or no? I just want to ask you, can REAP change the data, like change the data path, and can REAP send the data from 20.1 through 20.2 through the 40.1 and 40.2? Can REAP do this? Saifal Rafiq, if you want complete lecture, follow me on YouTube. Okay, in the YouTube, just search Bhavesh Shatara, you will get all the videos. Okay, I'm uploading all the videos, but right now maybe there is a 15 is going on. Okay, so you can able to watch this from that particular platform, YouTube. Yeah, can I repeat the question? My question is, okay, Nitish Sharma is saying yes. Okay, let me wait for some other comment also. I'm going to repeat my question again. Okay, if primary path goes down, can REAP switch over? Can REAP switch over to the secondary path? Okay, this is my question. We have same lab for REAP and primary path is like 80.1. If this path goes down, can REAP switch over to other network like 20.2? Okay, Nikhil Wag is saying yes. Swami Goda is saying yes. Okay, Rajkumar saying yes, AD value, or no, forget about AD because I'm talking about only REAP. Yeah, Rajkumar, we are not talking about like I'm having REAP, EIGRP, OSP all together. No, I'm just talking about REAP. Dinesh Arya, new player, welcome. Yes. Varun is saying yes. Okay, good. For REAP, it is yes. So now my question is, for what about the OSPF? What about OSPF? Yes or no? Yeah. Now type for OSPF yes or for OSPF no. So I can able to differentiate that for which particular protocol you are talking about, right? So yes. Okay. For OSPF or for REAP, Brijesh bhai, for OSPF or REAP? Okay. So for OSPF, you are also saying yes. Okay. For REAP, you people all are also saying yes. So what is the advantage? Like why EIGRP, REAP don't have this feasible successor, right? REAP don't have this feasible successor and all this concept. OSPF don't have this feasible successor and successor concept, right? Now EIGRP having this successor and feasible successor concept, right? So my question is, if REAP can do this, if OSPF can do this, and even EIGRP is doing this, so why EIGRP is going to work with the successor and feasible successor? So what is it can be? Do you know any idea about this? The advantage of successor and feasible successor? Yeah, Mark is saying really, yeah, it is really right. Like don't know for OSPF, but I think yes. Yeah, okay. Yeah, it is yes, Mark. Now you know this. This is yes. Okay. So what I am saying now, if REAP can reroute the traffic, if EIGRP can reroute the traffic, and even OSPF can reroute the traffic, okay, what is the advantage of successor and feasible successor of EIGRP? Because EIGRP works on cost, okay, but what I want to ask you is why EIGRP is different than the REAP and OSPF. Okay, so now you can able to understand the total concept of a feasible successor. That what I want to explain you, and that's why I'm asking you all this question. Okay, so now let me explain you. Okay, no more suspense. Let me explain you this. The first process is that you need to understand is REAP don't have second path. Okay, suppose if I'm talking about REAP, okay, REAP will accept only one path. Okay, REAP will accept only one path. Okay, like REAP will say that, okay, I'm having a best path which is 80.1 and I don't want this 20.2 because I'm already having the best path. Yeah. Now, if the 80.1 goes down, if 80.1 goes down, okay, now REAP then we'll find out the next path. It is like that. I don't have any backup. Now, if something is happening like electricity goes down, at that time I'm arranging the electricity. Yeah. So I'm like, what I'm thinking right now, like my process is like, okay, I'm having electricity over here. I have a connection of this. In our India, we have this. In Gujarat, we have this PGVCL. Okay. So no need to worry. And if something happen, like if light goes down or something will happen, electricity goes down, I will arrange this. Okay, I don't have any provision right now, but I'm saying that I will arrange this. Okay, so this is the process for REAP, and this is the process of in the OSPF as well. So actually what is happening for the REAP and OSPF is they don't have second path. Okay, they're only accepting the best path. Like if I'm having the best path, okay, I don't want second path. Okay, and I will accept second path when my first path goes down. So when my first primary path goes down, okay, I will calculate the second path. Okay, and in the real emergency situation, if you are counting this, like if really traffic is going on and everything is going on, working, router working with the very high range of processor, okay, and then it is like searching for the second path, okay, and it will take time and it will maybe delay this. Right, and actually the TCP/IP timeout timer is at 9 seconds. So if you cannot able to reconnect 9 seconds within a 9 second, user like the session will be disconnect. But in the EIGRP, we have this advantage. The advantage of the EIGRP, it has already know about the second path. Yeah. So I know that if electricity goes down, I'm having this like a UPS and everything. So whenever if the electricity goes down, I'm having the provision system, so it can able to start the electricity without any interruption. So the biggest advantage of the EIGRP over here is it has already a second path. It calculates the second path, okay? And now in the emergency, it will not find out the path. It will not going for, like, it will not search the path because it has already path in his topology table. Okay, so the switchover will be very quickly and very effectively in the case of EIGRP. Yeah, and this is a loop free path. Now, how it is a loop free? There is a feasibility condition. There are many things. Okay, that I'm not going to disclose you all, because some of the topics are from CCNP also, right? But this is what the difference between REAP OSPF and EIGRP. You can put EIGRP into the different category. Okay, and because of this successor and feasible successor, the redundancy and we call it the resiliency is really very high. So if one path goes down, EIGRP will not search for the second path because it already having the second path. But REAP and OSPF will search for the second path. Okay, so this is the difference between the EIGRP, OSPF, and REAP. Okay, we can OSPF and REAP, we will put one in the one category, and EIGRP is a totally different, right? So now is it clear? Like, you guys clear about successor and feasible successor? If it is clear, type clear, and if it is not clear, you can ask me question. Prasant Kumar, good evening. Good evening. No need to say sorry. We are here to learn. Okay, enjoy the training. That's all we want. Enjoy the training, pass the exam, pass the interview. This is what we require. Yeah. Okay, Nikhil is saying yes. Good. Okay, so now it is clear, successor and feasible successor. Yeah. If you are not typing like any comment, okay, it means like you are not able to understand this. Okay, so either type the clear word or otherwise. Okay, so Swami Gowda is saying not clear. Okay, Swami, do one thing. Okay, tomorrow I will ask you some questions. So what you can do today, you just watch the videos of all books, read the books about all this EIGRP concept, right? And tomorrow I will ask you some questions, and if you are not able to clear these questions, then we will talk about this, because right now the majority of people is saying clear, so I cannot repeat the process. And if you can able to answer all my question, I can give you 30-minute extra Zoom session, right? And I will clear all your concept. So don't worry about this. Today we'll do this. Okay, I will ask you some question. If you're able to answer all the question, I will give you 30-minute Zoom session. Okay, and I will clear all your concept, because right now majority people are saying clear, so I cannot repeat the process. It is done. So now let me open the mind map, and this is all this is done. Okay, let me open this again. Like, we have this neighbor table. Okay, we have this topology table, this is routing table. So all this process is done. We know about the successor, we know about the feasible successor, we know about the reported distance. It is a feasible distance, right? So now I'm going for the 9th point. Okay, you know that administrative distance of EIGRP is 90. Okay, and the second thing is it is like internal and external. Okay, so here we have this different thing. In the REAP, there is no internal external administrative distance. Okay, so right now you know that 90, like, it is a most trustworthy protocol, then the static, then the REAP and OSPF, right? Now I will explain you about external later, because before we learn about this MPLS topic, I have to explain you one process called redistribution. Now, what is redistribution? Redistribution is like, if my one network is connected with the OSPF, my one network is connected with REAP, okay, and I want to exchange route between them. So I must have to configure one border router which is having REAP and OSPF together, and then I can configure redistribution. Now, if I'm configuring redistribution in the EIGRP, I'm able to get reap route into the EIGRP, right? Now, like EIGRP considering this particular type of route, which is coming from other routing protocol as an external route, okay? And if it is an external route, like this routes are not coming from these routes are not coming from EIGRP, it is coming from REAP or OSPF or from any other routing protocol using redistribution, I will consider it as an external route. And if it is an external route, the AD of this particular routes will be 170. This is what the terminology of the EIGRP. Yeah, but without practical, you may not understand the process. Okay, so we'll talk about this later when we will talk about the redistribution. Okay, and you guys do not need to remember this. I will explain you this. Okay, I know this. I will explain you this particular topic when we will talk about redistribution. Okay, use RTP as a transport protocol. This is really good topic. Okay, now I want to ask you one question. What is TCP IP and UDP? Sorry. Going to repeat question. What is TCP and UDP? What is TCP and UDP? You can comment anything that you know, right? You can comment anything that you know. Question is, what is TCP and UDP? Okay, I'm not asking you the difference between TCP and UDP. Okay, I'm putting the same, like UDP and TCP is in the same bucket. Okay, and you have to give me the answer, like what is the function of TCP and UDP? No. That's what you are. This is what the mistake is. I'm not asking you like, what is the difference between TCP and UDP? Yeah. And my question is, what is the function of TCP and UDP? Yeah, that's what I'm asking. Okay, Prakash Kumar is saying TCP is connect. No, I don't want to know this. Okay, Raj Kumar is saying handshaking UDP is a postmaster only. I don't want to know this. Okay, I don't know this. What my question is, just listen the question carefully. Okay, the question is, what actually TCP and UDP is doing? Yeah, this is what the answer, like protocol is used to transport layer. It's a protocol of the transport layer. Okay, it's a protocol of transport layer. Okay, now tell me, what is HTTP? Okay, my question is, what is HTTP? Rajkumar is saying data transfer. Okay, it is protocol to move the data over the internet. Okay, Nikhil, if I'm having two computers without internet, can TCP work or not? TCP or UDP, can it work or not? Okay, Prakash Kumar is saying packet transmission, good. Okay, Prasant Kumar, okay, it is like, okay, it is okay. Now Mark is saying protocol of application layer. Yeah, HTTP is a protocol of application layer, right? HTTP is a protocol of application layer. This is what the right answer. Okay, so now I'm going to explain you something like that you can, like, you will understand the process. Okay, let me open my whiteboard. Okay, see, we have many protocols, right? 1 minute, I have to charge my pen. 1 second. Yeah, it required only 2 minutes for charging, so you can wait, guys. Yeah, 2 minutes. Okay, what is SNMP? What is SNMP? Okay, don't say me full form, huh? Actually, I know that. What is the full form of SNMP? So just tell me what is SNMP. Okay, now I'm going to start this. Okay, first of all, we have like TCP, we have TCP, we have UDP. Okay, so now this is a transport layer protocol. Okay, in short, you gave me answer. Okay, we have this HTTP, we have this SMTP, we have this SNMP, right? So these particular protocol are like from application layer. Okay, application layer. Now what I'm going to explain you, that keep this in mind. Okay, see this. This protocol are actually producing the data. Like you are able to access the web pages, it will transfer through HTTP. If you are monitoring your device, it can be go through the SNMP. If you are sending email to someone, it can go through the SMTP. It is a simple mail transfer protocol, right? Okay. Now this protocol is actually data producer. Like it is an application that is running on our system. Okay. Now, this particular protocol having a problem. Like this particular protocol cannot travel alone. Okay, so this protocol don't have capability to travel into the network. So actually the system is, they can use TCP and UDP as a transportation system. Okay, so actually TCP, IP and UDP, we can say that it is a transport system of all these protocols. So this particular protocol are passengers. Okay, and this particular TCP and UDP are transportation system. So whenever you are sending the data, this SNMP packets will be generated, and the TCP is responsible to transfer the packet from one computer to another, right? So this is a transportation system. Okay, now in the system, some situation, like we require, in some situation we require reliability. Okay, so what I am saying, like I want to go from one city to another, but I will not prefer speed. I will prefer reliability. So some protocol require reliability. Now the protocol with the require reliability use this TCP. And sometimes it's happened like I have an emergency situation and I can say that, okay, I don't want any reliability, I want to reach as soon as possible. Okay, so some protocol required speed communication, like that required low latency communication. In this situation, this type of protocol is using like UDP. Okay, so like HTTP is using TCP, SMTP is using TCP, but SNMP is using UDP. Okay, we are using this VoIP, right? VoIP, voice over IP. So in like right now, my session is going on and totally depend on the voice and video. Yeah, if you are not able to get my voice and video properly, you cannot able to enjoy the session, right? So in this particular, that required UDP communication. So for VoIP, like VoIP is using UDP. Okay, no, and why? You already gave the answer, like TCP is a connection oriented and all this. Okay, we'll talk about this later. Right now, this is not the time. Okay, so this is a transportation system. We can say that this is car. We can say that this is a railway system. Okay, and we are this like SNMP. We are using this system TCP and UDP for the transportation. Yeah. Now, if you find out the internet, okay, they have this type of packet in the internet, that it can be the TCP packet and UDP packet, because all this particular protocol are sitting in the TCP or UDP transportation system. So we have this either TCP and UDP packet basically. Okay, now when I'm using this ping, okay, I'm using this ping we are using for the end-to-end communication, yeah, to verify the end-to-end communication. So now when we are using this ping, now ping is not using either TCP or no UDP. Ping is not using anything, but TCP having like ping is not using TCP or UDP, but ping having their own car. Like, okay, I will not use this TCP UDP public transportation system. I'm having my own car. Can you tell me the transport layer protocol that ping is using? Can anyone tell me which transport layer used by ping command? Waiting for your reply. If you don't know, no problem. Nikhil Wag, very good. This is really right answer. It is using ICMP. No, Rajkumar, this is wrong. Okay. TCP/IP, ping is using ICMP as a transport layer protocol. Yeah. Nigappa, yeah. Okay. Yeah. Done. Yeah. Okay. Okay. Getting answer properly. Okay. Done. So ping is using ICMP. Now, any application layer protocol which is working, they require either they can use TCP, UDP, or they can ICMP in some type of protocol. They have their own mechanism. Okay. So now I want to explain you like EIGRP is not using TCP, it is not using UDP, it is not using ICMP as well. Okay, EIGRP is using RTP as a transport layer protocol. Okay, so basically when we talk about REAP, when we talk about REAP is using UDP as a transport layer protocol. TCP and UDP are only two transport layer. No, there is option. I already talked about this, like where is TCP, UDP, ICMP. Okay, we have this RTP is also transport layer protocol used by EIGRP. So same like ICMP, EIGRP also on his own car. Okay, it is using RTP as a transport layer protocol. Okay, OSPF is also using OSPF as a transport layer protocol. Okay, so keep this in mind. Like, let me give you detail of all. Like REAP is using UDP as a transport layer protocol. Okay, EIGRP is using RTP as a transport layer protocol. Okay, OSPF is having this OSPF as a transport layer protocol, like it has the same name. Okay, and we have this BGP. Okay, so BGP is using a TCP as a transport layer protocol. Okay, so this is what what is the RTP, right? Now the question is why EIGRP is using RTP as a transport layer protocol, like any specific reason? If I'm having like already TCP and UDP, why should I have to build that particular protocol? Why should I do this, right? Why they created this RTP for the communication of EIGRP? Yeah, they can use this like TCP and UDP. So years ago, okay, TCP/IP is not only protocol for the communication. There was a mix. There is a heterogeneous system. Okay, and we have like a TCP/IP was there. Okay, we have this IPX, SPX. Okay, it is called Internet Packet Exchange, Sequence Packet Exchange, and we have this AppleTalk also. Okay, so now, like at that time, like when the EIGRP was invented, EIGRP was the protocol. EIGRP is the protocol can able to route TCP/IP, IPX, SPX, AppleTalk like any protocol. Okay, and it was the advantage at that time. It was the unique selling point of the EIGRP. Okay, and it was Cisco proprietary also. So if you want to buy this multi-protocol supported routing protocol, you have to buy Cisco router, because Cisco, like EIGRP was Cisco proprietary. Okay, but right now we have this TCP/IP only. Okay, and because if I'm only used to route TCP/IP, okay, I can use TCP, but I am able to route TCP/IP traffic, IPX, SPX traffic, AppleTalk traffic. So I will not rely on this particular any TCP or IPX or anything. I am having my own transport and I can route the traffic of anything. That's what the philosophy of the EIGRP, right? So that's why EIGRP is using RTP. And the second thing that you need to understand is EIGRP is like a modular protocol. Okay, the modular protocol means what? Okay, it is used like when it was invented, it is supported by each and every protocol, like it is like layer 3 protocol which is running on, and the build like modular. So in the future, like if something new is coming, okay, EIGRP do not need to add the new version. Okay, it can be supported by adding the modules. It was the EIGRP that it is a modular based protocol. And because of this, when we are using EIGRP for IP version 6, we are not talking about any version. Yeah, we are not talking about version. They just added the module, and now this EIGRP supporting this IP version 6. Okay, so for example, let me talk about this. See, we have REAP. Now REAP is not modular based. Okay, so when the IPv6 comes into the picture, they have to build the specific new REAP, and we call it REAP NG. Okay, let me talk about OSPF. We have this OSPF. Okay, we have OSPF version 2. It is for IP version 4. Okay, and we have this OSPF version 6. Okay, which is for IP version 4 and IP version 6 as well. But in the case of EIGRP, we don't have this new version. Okay, same EIGRP is supporting IP version 4 as well as IP version 6. Right, and we will configure today, like we will configure this particular system today. Right, so this is what, like, the single line took 15 minutes to explain. So RTP is a transport layer, okay, protocol of TCP. Clear? If it is clear, type clear. And if you want to ask any question, if you have majority, I can answer this. Okay, yeah. I'm waiting for your comment. If it is clear, just tell me it is clear. Bridges Panchal is saying clear. Okay, Nikhil Wagh is saying clear. Okay, good. Okay, and okay, Neeraj is saying clear. Done. So this is what the dual algorithm, I already talk about this. Okay, like the thank you, Mark. Clear and wow. Thank you. Okay, so I already talk about this, like use the dual algorithm, right? So the algorithm of EIGRP is considered as a dual. Okay, so this is done now. Now I'm going to close this. Okay, I'm going to close this particular topic also. Okay, clear, but I want to know about BGP. Yeah, Varun, we will talk about this BGP. Don't worry. Okay, it is in our syllabus, and I will clear all the point which is in syllabus. But right now we are talking about EIGRP, so to concentrate on EIGRP. Okay, we'll talk about BGP. Yeah, because see, whenever I will talk about this BGP, you will think about like what is this automation is. Okay, so stay with the current topic. I will clear everything. Yeah, don't worry about it. Okay. So we'll use this IP version 4 and IP version 6. Okay, so there is one difference between IP version 4 and 6. Okay, we have this multicast, like in the IP version 4, EIGRP sending multicast hello packet on the 224.0.0.10. Okay, here we have this multicast address FF02::A, right? And use network command to advertise the network. Here we can give the command directly on the interface. Okay, so what I'm doing right now, I'm going to configure both IP version 4 and IP version 6 in the GNS. Okay, so you can able to understand the process, right? So let me go to the GNS. Okay, my system powered off. Wait a minute. Yeah, okay. So my lab is ready, and I'm using same IP. Yeah, I'm using same IP 10, 20, 30, 40, 60, 2001, AABBB. It is like a same. Okay. Now I'm going to configure EIGRP. I'm going to configure EIGRP. And then we'll talk about this EIGRP version 6, right? So I'm having this lab. I'm going to configure EIGRP with IP version 4. So IP root. Okay, there is a 2 network which is directly connected with me. One is a 10. Sorry, I'm in R1. I'm in R2. So IP root. Okay, so this is a 10 and 20 which is directly connected with me. Okay, and now I want to configure EIGRP. So I will configure like this: router EIGRP 10. I'm going to configure IP version 4, okay, IP version 4, okay, because there is a reason. That's why I'm going to configure IP version 4 with this particular lab, okay. So 10.0 and we have this 20.0. In R2 router, here is this 2030. Wait a minute, I have to check IP address first. Yeah, it is administratively down, so no shut. Okay, now I have to check this. Yeah, there is a duplicate IP also. Okay, interface fast Ethernet 0/0, going to change IP 192.168.20.2 255 255 2550 and no shut, right? Do so IP interface brief. Okay, now it is okay, seems okay. Router EIGRP 10, going to add 192.168.20.0. Okay, the neighbor relationship must be there. Okay, now 40 and 30. Okay, going to R3, router EIGRP 10, network 192.168.40.0, done, 50.0 and 60.0. And now in the R4, router EIGRP 10, network 192.168.60.0 and 70.0. Yeah, so this is IP version 4 EIGRP. Okay, I want to explain you the advantage of name mode, and I want to finish name mode today. Okay, that's why I'm going to configure this IP version 4, right? So now I'm in R1 and I want to verify the routing table. So I'm getting this 192.168.70. You have this course calculation, everything seems okay, right? Now I want to configure IP version 6. I want to configure IP version 6 like routing with the EIGRP. Okay, so the command, I want to check the IP address. So IP v6 interface brief. Okay, I'm having two interface. Okay, here the IP address is right. Okay, so up everything is done. Okay, so if I want to configure EIGRP, I have to configure like this: IPv6 router EIGRP 10. Okay, this is the way. But here we have this good advantage that in this particular lab, IPv4 is already configured. Okay, so if I will not going to give this command, it is okay. I just need to enable on the interface basis. So I can go to the interface fast Ethernet 0/0. Okay, this is a interface which is connected with R2. Okay, and I can give the command IPv6 EIGRP 10. Okay, this is the only command that I need to give. Okay, now interface 2/0, which is my Ethernet network. Interface Ethernet of fast Ethernet 2/0. Okay, IPv6 EIGRP 10. Okay, going to R2, I am going to do it very quickly. Interface fast Ethernet 0/0, IPv6 EIGRP 10. Yeah, this is 10 is AS number. Okay, so it must be same IPv6 EIGRP 10, INT fast Ethernet 2/0, IPv6 EIGRP 10. Okay, let me verify because maybe there is a problem with IP. IPv6 interface brief. So IPv6 interface brief. Thank you, Mohammed. We have 20.1. Let me ping 2001:20:2. I'm getting ping. Okay, it is done. So it is okay. Let me enable all the way and then we'll talk about this. If we will not get anything, I will solve this. Okay, IPv6 EIGRP 10 interface fast Ethernet 2/0, IPv6 EIGRP 10 interface fast Ethernet 0/1, IPv6 EIGRP 10. R4 interface fast Ethernet 0/0, IPv6 EIGRP 10 interface fast Ethernet 2/0, IPv6 EIGRP 10. Right? So it is done. Let me check. So IPv6 EIGRP, sorry, so IPv6 root I'm not getting any root. Okay, so let me verify this. So IPv6 protocol. Okay, see, I'm not getting any protocol also over here. Okay, so what we can do, go to the EIGRP IPv6 router EIGRP 10, okay, and give command no shutdown. Yeah, router EIGRP 10, no, sorry, IPv6 router EIGRP 10 and no shutdown. See, the neighbor relationship has been up. This is what the no shutdown here that we need to use. Okay, going to R3 IPv6 router EIGRP 10, and I have to give like no shutdown, and it is like based on something depend on the version. Okay, so IPv6 router EIGRP 10 and no shutdown. Yeah, so it is done. Now I'm getting this. Okay, keep this in mind. If I'm in the REAP, there is a config router, and if you are in IP version 6, there is a config dash RTR. Okay, so keep this in mind. Now, actually, I configure IP version 4 EIGRP, EIGRP for IP version 4, EIGRP for IP version 6. But actually, both are totally different. Okay, both are totally different. If I want to configure IP version 6, I can go to the like IPv6 router EIGRP. And if I want to configure IP version 4, I can go to the IP router EIGRP. Okay, so there is like a different command. Okay, like I want to configure IP version 4. The command would be like router EIGRP 10. If I want to configure IP version 6, so IP version 6, router EIGRP 10. Like there is IP version 6 packet, hello packet, everything is going on. Okay, so here, let me check the routing table. So IPv6 root. Okay, and here I'm getting this all the roots. Okay, there is no difference in the course, nothing. We are using same version. We don't have this different EIGRP version for IP version 6 and IP version 4. But we are using two separate command line, two separate configuration mode to configure this. But if you are using named mode, okay, if you are using this name mode, it will be really awesome, and you can able to configure IP version 6 and 4 together. Okay, if you want to use this new VRF MPLS, okay, in the MPLS you have to use this VRF, and if you want to learn all this concept, you have to understand EIGRP name mode. Okay, and in the EIGRP name mode, if like we have this 10 giga interface, in the interface delay would be in the picosecond. So the EIGRP course calculation will be changed for the name mode. Otherwise, what happened? Now this particular EIGRP cannot able to support 10 gig interface. Okay, so we have this new name mode. Okay, and that's why it is really very important, because see, when we talk about MPLS, I have to explain you, okay, what is VRF. And now if you want to configure VRF with your with the routing protocol, okay, you cannot configure VRF with this particular mode, which is known as classic mode. And that's why I'm actually building this pillar. Okay, so when I will teach you about this MPLS and all this, okay, I can say to you, okay, we'll configure name mode EIGRP over here. That's it. Okay, and that's why it is really important. Don't worry about this syllabus and all this. Okay, we will talk about this. We will configure EIGRP name mode today, right? So now let me remove this EIGRP. Now we got this, everything is okay. Okay, there is only differences like the addresses and all this. Okay, we just configure on the interface. Okay, in here we are using this network command, right? So now let me remove EIGRP together. Okay, so I will like no router EIGRP 10, no IPv6 router EIGRP 10. R2, no router EIGRP 10, no IPv6 router EIGRP 10. AS concept, everything remains same. Okay, router, sorry, no router EIGRP 10, no IPv6 router EIGRP10. R4 no no router EIGRP10, no IPv6 router EIGRP10. Then no IP version 6, no IP version 4, everything is clear. So IPv6 root, okay, directly connected network only, and so IP root only directly connected, right? Now I'm going to configure name mode. There is a single command, and then we can able to configure both in the same mode. Okay, so let me go to the configure, like let me configure EIGRP. I can give like this router EIGRP, and we can like CCNA. This is a named, yeah, you can give any name, doesn't depend on the neighbor. Okay, you can give CCNA over here. If you want to go and give the CCNP over here, no worry, this is a local value, right? So it is like a router EIGRP CCNA. Now I want to configure IP version 4. Okay, so the command would be like address family, okay, which you want to configure IP version 4 or 6. Hello real. So it is like IP version 4. I want to configure IP version 4, right? Now there will be the multicast, unicast, and VRF. Okay, you don't know anything about VRF. I will talk about this, but right now we are using actually unicast routing. So you have to like a unicast. Now if you don't want to use this word, it is okay. The default mode is unicast. Okay, and we have to specify autonomous system. So it is like a 10. So address family IPv4 autonomous system 10. It means I'm going to configure EIGRP for IP version 4. Now I have to use this command like network 192.168.10.0 and 20.0. It is done, okay, with IP EIGRP name mode in the router. Okay, now this is called address family. Okay, and it has a many advantage, but right now I'm short of time. So what I'm doing right now, I will just explain you how to configure. Okay, then we will talk about later, like tomorrow we'll talk about something. 15 minutes we will spend it for the EIGRP name mode. Now in the router R2, router EIGRP, and if you want to give different name like CCNP, okay, now address family IPv4 and autonomous system number. Now it must be same as my neighbor, right? Because in the EIGRP the AS number must be same. Okay, going to add 192.168 20.0. got my neighbor relationship status 30 and 40. Okay, now going quickly, router EIGRP, yeah, CCI, address family IPv4, autonomous system number 10, network 192.168.40.0, 50.0 and 60.0, right? Going to R4, router EIGRP AWS. You can give any, okay, address family IPv4, autonomous system number 10, and I'm going to add this network 192.168.60.0 and 70. Got it done. Okay, and here I will get so IP EIGRP, sorry, so IP root. Yeah, see, I'm getting different type of cost. The cost calculations has been changed when you are using EIGRP because it is using picosecond and all this. Okay, we'll talk about it later, but right now I'm getting this D. Okay, AD remains same. The way I configure EIGRP is changed. Okay, and now last 5 minutes, and I want to configure same IP version 6. Okay, so what can I do? You can configure like this: IPv6. Sorry, do not need to use this. Okay, like router EIGRP. Okay, and this is like CCNA. And now I want to configure IP version 6. Okay, so it is like address family IP version 6, autonomous system. Okay, and I can set any autonomous system for IP version 6. Okay, so let me configure like 10, same autonomous system. Okay, and here is the, like a different thing. Okay, like I'm not going to advertise anything. Okay, I just leave it over here, and I'm going to R2. Okay. Now, if you are already in the EIGRP configuration mode, you will find it out in you are in the address family. Okay. So if you click or like if you give command exit over here. So now I am in the router EIGRP CCNP. Now what I am doing, address family IPv6. Okay, address family IPv6, autonomous system number. Okay, and I'm like using same 10. Okay, now 10. Okay, do you feel any change over here? Yeah, do you feel any change, guys? If you feel any change, tell me. Otherwise, I'm going to explain you. We are short of time. Okay, answer quickly. Do you feel any change? Okay, I can't wait for your answer. Let me go for R3 and R6. Okay, like I'm going to exit address family of IPv4. Okay, IPv6. Again, you will feel this. Again, you will feel this. Look at over here in the screen. Okay, address family IP version 6 unicast, unicast, autonomous system number 10. See, I got the neighbor relationship up with my neighbor. Yeah. Now R3 become neighbor of R2. And even though I do not advertise, I didn't advertise any network. Okay. So in the normal traditional EIGRP or in the EIGRP name mode for IP version 4, you have to advertise network. Without advertising network, the true router cannot become neighbor. Right. But in the IP version 6, it is becoming the neighbor. Okay, if you verify it again, let me go to the R4. Okay, address family IP version 6, autonomous system number 10. Okay, and I do not need to advertise the network. See, it become neighbor. No need to advertise network. Yeah, no need to advertise network. Now go to the R1. Okay, and then so IPv6 root, I am getting 10, 50, 60, 70. Yeah, so it what it means, you do not require to advertise network when you are configuring EIGRP name mode with IP version 6. Keep this in mind. With IP version 4 you have to advertise, but in IP version 6 it is not required. It will advertise directly connected network by default. Yeah, that is thing that you need to remember in the mind. Okay, because for NCORE exam they will ask you question about this. Now they are asking very little question, but maybe you will get this. Now just a final question that I am going to ask you now, and you have to answer it tomorrow. Okay, so my question is, see, I am in router R1. Okay, I just configured EIGRP name mode. Okay, and if you verify the routing table, like so IPv6 root, okay, two network 10 and 20 is directly connected with me. Please sir, why did you use unicast? Yeah, because in the routing we have two type of routing. Either we can use unicast routing and we can use multicast routing. Okay, like in the EIGRP paper we have this multicast routing protocol. Okay, so you can use this multicast route for multicast purpose only also. But like if you use this without specifying command, like if you use this address family IPv6 autonomous system 10, it works. Okay, it works because by default the mode is unicast. Now if you want to configure multicast, you have to specify multicast. Otherwise it is okay. If you mention there, it is good. If you not done, it works, right? Because the default mode is a unicast. Okay, so there is a like two type of routing, unicast and multicast both. And by default it is unicast. So if you mention it, okay. If you don't, no worries. Okay, now let me ask you the question. See, right now EIGRP name mode for IP version 6 has been configured in this router, right? And my router is advertising 10 and 20 by default, because in EIGRP name mode for IP version 6 you do not need to advertise your network. Yeah, it will advertise by default. Yeah, it will advertise by default. Now my question is, I don't want this 10 to be advertised. Like I don't want to advertise 2010 00 in the IPv6 name mode. Okay, I don't want to advertise 10. So I don't want in the 10 into the routing table of R2 or R3 or R4. Okay, I don't want to advertise 10. Okay, by default it is advertising, but I don't want to do this, right? So now how can you do this? You have to Google it, you find it out. This is not my problem. Okay, I will answer you tomorrow, but you have to give me answer first and then I will explain you. Okay, I'm going to ask you question again. Okay, this like you can understand it. By default, EIGRP name mode for IP version 6 advertising both the network by default, right? Like 10 and 20 is like advertised by default. But now I want to prevent, like I don't want to advertise 10.0 now. Okay, how can I stop this advertisement? Okay, this is my question, right? So it is done. EIGRP name mode. Tomorrow we'll talk about favorite protocol of you guys. Like 15 minutes will be for EIGRP and then we'll talk about OSPF. Okay, and it will be really interesting. Yeah, for OSPF it is also like good protocol, my favorite also. Okay, so we'll talk about this OSPF tomorrow. If you really like today's session, you can share this. There are permanent 8 people or 10 people. They are sharing my video daily. Bridges by Panchal. Okay, there are many people. Okay, thank you very much for sharing. Okay, and my only idea, like my only aim is, if you share this, many people will get this. Okay, and they will also get the proper training for EIGRP, for the CCNA, right? So please share this video if you are comfortable. If you are not, okay. Tomorrow we'll meet at 8:30. Thank you very much.